Hey everyone, today I want to do a deep dive into the type system and certain hooks that we can do with the type system to show you how we could implement an audit solution. So this actually was a question on our Slack channel, how you can implement an auditing thing where we essentially tag certain parts of our API and then would write a list of these used tags to an audit service. So what we want to get here is an idea of what kinds of data a user accessed. By the way, we are running workshops at several conferences throughout the next year. If you want to spend 2 days with Martin and me, diving deep into GraphQL in the .NET ecosystem, and also how to implement a full-fledged GraphQL application with React and Relay, then join us. If you like our content, please hit the like and subscribe button below the video. And with that, let's dive in. So I have not really done anything to this application. It's at the moment an empty directory. And we're going to create it step by step. We will use our template for that. And I have installed here the newest version of it, the preview 92. And I'm doing here .NET new GraphQL and then hit enter, and then we will have our famous books and authors example here. So let me maximize that and then let's just restore it. Okay, with that in place, we can basically start building our GraphQL server. So the first thing that we want to do is we're going to go to our types here, and you can see the author has at the moment just a name. So what we're going to do is extend this author type here with an address. And the address is marked as personal data. I introduced here the author personal data class, which extends our author type that we have here. So the idea is we don't want to mess with the actual implementation of our business objects here and just implement the GraphQL specific stuff as an extension to it. And in my case, I'm introducing here an address field, which might come from a different data source. And I would like to mark this address field here as personal data. So the way we could do that is by introducing a new attribute here that we could put on top of this extension data here. So essentially we want to do something like category and then personal, for instance. And while this attribute already exists in the component model here, we actually want to have our own version of it. So the first thing we want to do here is introduce a category descriptor attribute. And once we have that, we want to introduce a pipeline on our field here, or on the fields that are marked with this category attribute, and then aggregate some data on the context data or the result state. And this result state we're going to use later in a request middleware to aggregate the audit data. So let's just go through with it and I explain what I'm doing step by step while implementing this. So the next thing here is we're going to implement our attribute. So we introduce here a new class, category attribute, and this class implements a descriptor attribute. So I already showed a couple of descriptor attributes in other episodes, but this time we are using the base thing here. So we are extending here the descriptor attribute. And the next thing is our category has a name, which is read only, and we need a constructor for it. So our category attribute here has a try configure. It's, as I said, the base class, so it's not geared toward a specific descriptor. We have to try if the configuration actually can be applied to certain descriptors here. We also need to define in this case where I actually can annotate this attribute. In my case, I want to be able to annotate this on classes and on fields. But if I annotate that on a class, in this case on this extension class, I only want it to have effect on this very extension class. So I don't want that this category attribute actually has an effect on the name field up here. So let's first define the usage here. And the usage in our case is class, and then property and method, because we want to be able to annotate it on a field and then it just has an effect on this field, or on a class and then it just has an effect on everything that is covered in this class. So let's start implementing this. So the first thing is we limited this actually to class, property and method. The second thing is we want to limit it further in here to certain types of descriptors. And the first case actually is that the descriptor is an object type descriptor. And we are using here the interface because the interface iObject type descriptor is used by extensions as well as by the type. So this means you could also put the attribute on here and then it would only have an effect on this author here. So let's capture the casted instance here. In this case, we want to capture all the fields, as I said, that are scoped to this class, not to this type. And we're going to do that by using a hook that we have into the initialization system. So the type initialization of hot chocolate has certain stages. Like first are types created and initialized. Then the name is actually completed because we essentially have something like a generic construct here where for connections, for instance, we generate the actual GraphQL type from various type components. In many cases, the name is actually already complete in the initialization phase, but you only can be sure that it's completed after it went through the name completion step. The third step in our initialization pipeline is actually the merging of extension classes with their type classes. Essentially, at this state, we are merging the author personal data class with the actual author class. So let's do that. So first I'm using here our descriptor and there's an extend method on there and this is meant for such extensions. And on that I actually have a hook into the initialization events. And we are going to picking the on before naming after the creation and initialization of the type object that we have here, type object or extension object. And this hook has a delegate that allows us to capture the current context and the definition of our type object. The definition here is a mutable configuration object. So there's actually no validation around that. It's just the data that we have that is running through the initialization pipeline for this type. And we're going to use that to iterate over it. And now we have each field here and we're going to add a middleware to it. Usually you have the descriptor API and then you would start just with a use. In this case, we actually have the middleware definitions, which is an object where we can add a couple more things to our middleware. Now we have our field captured. Usually you have the descriptor API to just use the use descriptor for the middleware and then just provide the delegate. But the field definition actually allows to do more here. On the field definition, we have the middleware definitions, which is essentially a list, and we can add there a new middleware, and the middleware definition actually allows us to specify a couple more things. So let's first get the delegate in and then I explain the rest. So I have the middleware definition here and the first argument into it is actually our middleware. So I start with next. This is a typical pattern we use. Then we have an async middleware delegate here, which has the context. Let's call it CTX. So we don't overlay this context here. And then this is our middleware. We just now need to implement our logic here. And for now, let me just add here the next delegate. So we're invoking the rest of the pipeline and then we are good. This is actually a valid middleware now. It just doesn't do anything, but we will get to it in a second. So then comes the other thing. So we can say is repeatable and we say false. And that means that we only want of this middleware kind a single one. Even if this attribute is applied twice, then only the first will be executed. And in order to identify if it's the same middleware, we're going to add here a key and name this middleware. And this middleware is the category middleware. So this piece of code here is actually done. The one thing we have to add is actually the middleware logic. And what we want to do in here is essentially mark that we received or the user received a certain type of data. And for this, we're going to introduce a new method down here. Let's make it static. And we call that the track category. And we pass into that the middleware context and the category name. And here's something new for Hot Chocolate 13. So it was always a pain to write to the result extension data and the result state data. You could do that, but you would have to write something to the global state and then aggregate it somewhere in the request pipeline. So you would have to implement a couple of things here. In the new version, you can now access the result data or actually have a a couple of methods or helper methods to mutate the operation result data. So on the middleware context, you have now the operation result. And there are two methods and they are overloaded essentially. We have set extension and set result state. Set extension just writes to the extension object of the result, and you will have that visible in the serialized result object that goes over the wire. Whereas the result state is just to aggregate some data that you want to have on each result object in the result pipeline. And we're going to use the result state here. The set result state method has actually two overloads. One is just to put something on the result state, and the other one is to aggregate something on the result state. In this case, we want to write this property here, categories, and then we pass in as a state the category name here. And in the aggregation delegate here, we get the key, which we don't need in this case. Then we get the current value. So the value that is actually at the moment in our result state could be null. And we also get our state here. That's the category name. And here in our delegate, we just check if this is a hash set. If not, we create a new hash set and then we add whatever we want to this hash set. In this case, we're tracking the data categories that the user accessed. And then we return the new categories object to the state and it will be stored on the state. Okay, this is thread safe, so you don't have to worry about any other resolvers that interfere here, but you have to be aware that there is locking involved. Don't overuse it. And we're going to use this track category now in our middleware. So we use that here and say context into it, and then we capture the name here. With this done, we are actually done with this part, and that means we can now use it on a class and it will capture correctly just the fields here. The next thing we want to allow is to also just use it on a field. And for this, we implement another case here and say if the descriptor is an iObject field descriptor. In this case, we are going to do the same that we actually do in the for, but this time we just put it on the specific field. If you do an extend on any descriptor, you also get access to the underlying definition. Don't do that in the actual API, just in such extensions like this, because this gives you unrestricted access to the underlying configuration object. And as I said, it's not validated, as we want to create data throughout the initialization pipeline, and we want to be able to have maybe in the beginning some invalid configurations and then complete that configuration throughout the pipeline. So use it with care. So let's try that out and have another field here. For instance, let's create another field in here that we call the city. So the city where the person lives, and we put another category on this guy here. And we call that just location. So this is category location. So the next thing we need is the audit service. So let's just implement a little facade here. So I'm adding here an iAudit service.cs. The service itself is just basic. So we just report the usage of certain categories of data here. And we also report the user that is in our system. So let's next put a default implementation here. And in this case, I'm just printing this out to our console. In a real world situation, you wouldn't do that, and you would maybe have a completely different audit service. It should just show you the hooks, how to get that into your system. The last piece that we need to fill this audit service here is actually a request middleware. And a request middleware is essentially a piece of the actual GraphQL execution engine pipeline. And we're going to write such a thing in a class. So I'm creating a new class here and I'm calling it an audit middleware. And it's always good to have these things sealed. And we need to inject now into our audit middleware is the audit service, because that is the main thing we want to use. Let me actually push that in its own file. And then we also need a next delegate here. With the next delegate, make sure it's the hot chocolate one and not the ASP.NET Core one, because we named it the same way. And that is sometimes annoying because you get either the Microsoft one or ours. So for the middleware, we just use constructor injection here. The engine will actually actually handle that and compile a middleware gateway from this class and do all the dependency injection. So we just inject what we need, and then we introduce another method here, which is an async method, use a value task, and we call that invoke. And this invoke method will get the request context. And the important thing here, this is by convention. This method has to be called invoke. It has to use a value task, and it must inject here at least a request context. You can have other services injected into this method that are, for instance, scoped, so you can capture them in the method. In our case, we're gonna await the rest of the pipeline, so we call the next delegate here, and then we want to capture things that happened on the result object. So I'm ensuring here that the result is a query result. A query result is what happens if you do a single GraphQL request. And we can try that out in a second. And if I have this single GraphQL result here, then I'm looking if context data were aggregated. So if there's no categorized data, there will be no context data. And even if there's context data, I will make sure that the category state is on this context data. If not, it's not of my concern and I can just move on. If there are categories, I will send them to my audit service here. So let's wire that up. The first thing, I'm going here to my GraphQL configuration in the program CS. While the type registrations are automatically generated, like you can see, we have here the personal data already registered. We need to register our middleware, our request middleware here, because order is important in this case and we cannot generate that. So I'm starting here with a use request and this generic here. Then I'm saying I need my audit middleware. And after that, I have to opt into a pipeline. So I have to say I want to use this with the default pipeline here. You could also use that with other pipelines or create your own pipeline. There's one more thing we need to do, and that is setting up our audit service here. And then we should be able to start this. So I'm doing a .NET watch, no hot reload. I'm running that. Let's open a new tab, and then we can query here for our documents. If I query for the title and the author name, let's do that. I queried here. Now I'm going back to my VS Code instance and you see nothing is reported in our console here because this data was not being categorized. But if I now opt into address, for instance, then you can see we are printing out, okay, there's a personal data was being accessed by this request. And if I would go further and ask for the city, then I can see we are accessing location and personal data here. So this is great. But what if we use things like defer and subscription? Let's try that out. So I'm deferring now this, executed that, and now we can see that there's no new entry. Although I accessed this personal data, it's not being reported. And the reason for that is that we actually just looked into single results. And there are two result categories. There are result streams or response streams that we have in Hot Chocolate and query results. Response streams are everything like subscriptions or defers. So we actually have to deal with two kinds of data here. So in order to capture the subscription results, we're gonna add here another case to capture the response stream. And the response stream is such a deferred stream, something that is not completed yet. So there's more results coming. A response stream is essentially a stream of query results. So what we need to do here is essentially wrap this stream and then look at each of its elements. But we don't want to for each async over this in our middleware because then we would essentially buffer all the results and all the streaming effect is gone. So what we're going to do is introducing a new stream here. And this method that I introduced here called create stream essentially gets passed in the original stream, and we also get the user that is currently executing this stream, and then we start reading the stream, and for each response that we get, we report the usage if there was any usage of certain categorized data, and then we yield the result back to the execution engine that then can serialize it and send it to the user. So but this new stream has to be wrapped in the response stream class again. So what we do here is first capture the user. Essentially, we did the same here, but in this case, we just need it for a single result, so it doesn't matter. But here we capture the user in the beginning. Then we create a new response stream. And in this response stream, we pass a factory to create this stream. So the transport middleware will actually execute this read results on the result stream object, and then this delegate is executed, which creates our stream here. And then the transport layer will start iterating over the async stream. We also mark the stream as a certain kind, could be defer or whatever. We just copy that from the original stream. And we also copy the stream context or the stream state from the original stream and just path it through. There's one more thing we need to do here, and that is we need to register the original stream as a thing for cleanup. So whenever the outer stream is disposed, we want the inner stream to get disposed as well. With this, we actually wrap now our stream correctly and we can restore it on the results. Okay, our server should have rebuilt, and then we can just go to Banana Cake Pop, rerun this, and then we go back to VS Code, and we can see now we track here location and personal data. So this now covers all cases, like the response stream case and the query result case. While there were a lot of moving parts to it, I hope it showed you how you can implement such things where you essentially can aggregate data on the resolver level, then reuse that on the request level and do things with it. As I said, this actually came from a user question on Slack, and what I liked about this was a bit the challenge to get that working and to have this story around it that makes it more accessible to everyone listening here, because there was this concrete use case behind that. If you want to help our project, please go to GitHub and give us a GitHub star. And with this, I'm out. See you next time.